All right, for this lesson, we're going to take a look at geometric series. So just like with the arithmetic, series simply means that we're finding a sum. And so that's why for this formula, you're going to see the S of n formula. So let me show you one more time here. These are the 5 formulas that we've been looking at for this chapter. We'll be getting into this guy later on in the next lesson, but these were the 2 for arithmetic. And so you had the one that deals with specific terms, and the S of n was for the sum of an arithmetic series. In the last video, we looked at a geometric sequence, and this was for finding specific terms. And in this video, we're now taking a look at sums for geometric series. So remember, the difference between a sequence and a series is if you took a sequence and add all the terms together, you are now finding a sum, which we call a series. So a series is just the sum of a sequence that we have. But anyway, take a look at the formula that we're working with. U1 we know is the first term in the sequence. R is the common ratio. N is the number of terms that we are adding. And those are the only 3 pieces we would need to know in order to find the sum. So taking a look at a couple examples here. So the first one says find the sum of the first 9 terms. So just a reminder on this, we could, if we wanted to, do this without a formula. And I could simply identify what the first 9 terms are and add them together. And that works. But we are dealing with efficiency in this case. And so, if the formula is more efficient or quicker, that's something we would want to take advantage of, especially when you get to some more complicated cases like this with fractions and decimals. You definitely need to know the formulas. So here we go. So find the sum of the first 9 terms. So again, I need to know the first term of the sequence is going to go right here. So that's a 2. So we're going to put a 2 in for this guy. R is the common ratio. We can see clearly that I am multiplying by 2 every time to get the next term. But if you couldn't tell, then you simply take any term and divide it by its previous term to get the common ratio. So if I did 4 divided by 2, I would get 2. So there's our R value, the common ratio. And then the number of terms, it says we're going to find the sum of the first 9 terms. So there's the number of terms is 9. So if I just sub in the information into the formula, this would be the sum of the first 9 terms of the sequence. Give that a try. If you're toying with your calculator on this one, plug those numbers in, make sure you're coming up with this. If you do take a look at the formulas, you'll notice that there are 2 different ways to write this formula. This one does the r minus 1, r minus 1. This one does the 1 minus r, 1 minus r. Either case works, but I always encourage students to go with this format because students often run into an issue with the negative and the exponent over here as far as order of operations. It causes some issues. So this is the safer approach. So we're going to go with this format right here. Looking at another example, again, same idea. If you're trying the video here for the first time, you might want to pause and give this one a shot on your own. But if we sub into the formula like we did on the previous one, again, I have my first term is 24, so that's going to go in for U1. The common ratio is a little tougher to identify on this one, so again, you might want to try the division trick and do the second term divided by the first term. So I did negative 18 divided by 24, and if I reduce, I have my common ratio of negative 3/4, so that is going in for R. Remember to put that into parentheses. Anytime you sub in a value, you should always sub in with parentheses. It's the safer approach. Sometimes that matters and sometimes it doesn't, but it's safe to always do it that way. Again, I'm finding the sum of 9 terms, so we're going to put a 9 in for n, and the rest is calculator work. So a little trickier with calculator on this one because of all the fractions going on, so you might want to give this one a try. Keep in mind that we can do these as decimals or fractions. Your calculator will give you these fractions, so as always, if you just hit the math button, and then the first option is fraction, so just hit enter, enter, and it will convert your decimal into a fraction. So this is the more common approach for writing answers, is in fraction form. So this is the one I would get used to. All right here we have, again, we're finding the sum. But in this case, they're providing the info in a little different way. We don't know how many terms are involved here. So I know I'm going to be adding all the terms from here all the way up to here, but we do not yet know the number of terms that includes. So that's going to be this is going to sort of a 2-step process here. is I first have to use the U of n formula to find the number of terms. Then I can use the S of n formula once I know the number of terms to go ahead and find the sum. So here we go with the first part. I first have to start by figuring out how many terms are involved. So looking at the U of n formula from yesterday's lesson. So again, here was the U of n formula that we're using for this one. So I need to know the first term, the common ratio. Keep in mind, this is key on this formula, is this n is the number of terms for this value. So if this is the 20th term, then this would be the value of the 20th term. And so there's always a connection between the U of n and the n. And so we got to keep that in mind as we do this guy. So I need to know what term number has this value. And so I'm going to take the value of 196,000 and plug it in for U of n. I got the first term. We got the common ratio. And now I can solve for the number of terms. And so there's two approaches to this. I addressed this in the last video, but you can either use logarithms like I did here, or you can use the graphing technique on your calculator. And I'm going to show you that really quick just to remind you. But anyway, if you were going to take the algebraic approach, with this setup, you would start by dividing both sides by 3. You then have to convert this into log form. So if I took this expression and converted it to log form, it would look like this. This can now go in my calculator. So if I did a log base 4 of this, that's going to give me 8. And then when I add 1 over to the other side, I get my term number of 9. And so this could all be done in the calculator. I'm going to show you that really quick. But this is the one where you're going to go under math and you're going to choose option A, which says log base, and we're going to sub in the information for that. So we got a base of 4, and then I got to remember this here. So 65,536. So we're going to go to into this. So I went into the math button, and then I scrolled down to the one that says log base. Choose that. We had a base of 4, and then 65,536. Hit enter, and there we go. We got 8 as our solution. So again, keep in mind for this one in particular, if this is equal to 8, to get n by itself, I'm going to add that 1 over and get 9 as my answer. So that is not a hard way to go. There is the graphing approach to solve any equation, and that's simply where you graph this as one graph, you graph the right side as another graph, and then you figure out where those two graphs are equal or where they intersect each other. And so if you were to do that, I'll bring that up as well. So if you go to your y equals, so I already punched this one in, but I did the left side as one equation, did the right side as the other equation. Be careful with the x minus 1. Make sure your calculator identifies the minus 1 as part of your exponents. If yours doesn't raise it up like mine does, then just make sure you include parentheses around the x minus 1. And that's a safe way to go too. Anyway, keep in mind for a number this large, that's almost 200,000. So I had to go to my window and adjust my y max all the way up to 200,000. Otherwise, you'd never see this on your screen. And so anyway, that's what I did. Go ahead and hit graph, and both graphs are graphed. I got the point of intersection right up there. So if I go ahead and hit second calc, choose intersect, and I'm going to get my cursor over into that area. And then as far as those questions go that they're going to ask me, first curve, hit enter, second curve, hit enter, guess, hit enter, and there you go. We get our solution that way, which is 9. Your other option, here's the third option we haven't really talked about, and that's to check the table. If you go under table, this tells you all the points for both graphs. So at 0, you can see the two solutions. At 1, here's both solutions. If I simply scroll down far enough, I'm going to find the case where they are equal, and that must mean that 9 is the point they have in common, so 9 is my answer. So that's another way to get your answer from this calculator. All right, going back here, Anyway, now that we know that there are 9 terms involved, I can now find the sum of these 9 terms. And so if I go to the new formula for today, got my first term, got my common ratio, I can now plug in a 9 for n and get my sum. And so there we go for that one. Getting down to the last couple examples here. In this case, we now know the number of terms is 11. I know the common ratio, and I know the sum. But in this case, they left out the first term of the sequence. And so, again, just recognize in this one which formula is needed. The fact that they gave me a sum tells me I need the S of n formula. So I'm going to sub this in for my sum right here. I'm going to leave U1 as U1 because that's what we are solving for. I know the common ratio. I know the number of terms. And so now we're just solving for U of 1. So if you're doing this in steps, I would take my 3 minus 1, which is 2, multiply 2 over to the left to get the fraction gone. I would then divide this answer, whatever it is in your calculator, over to the other side, and that would give me U1 by itself. So there we go. First term was negative 4. Last one, sums can always be done in your calculator with the sigma notation, so I'll show you that one more time. I'm just going to split the screen this so I can see both at the same time. But if you go under your math button, let me hit quit and get out of that. So if you go under your math button, it's the one all the way at the bottom, so I actually go up in order to go down. So I'm going to hit up, takes me to the bottom of the list. And right there where it says summation, hit enter. And then you literally just sub in exactly what you see for the problem like this. It doesn't matter if they have a k or an x or whatever, just type in x equals 1. I'm going to put a 6 up at the top and then 2 to the k as my general rule for the problem. So let me go to that one. So I got x, hit, oops, and a 1 in that space. I'm going all the way up to the 6th term. And the general rule was 2 raised to the x power. So here we go. There's our setup right there, and I'm just going to hit enter. So there's the sum. Remember what this means, because this can be done by hand. You are finding the sum of terms 1 through 6 in this rule. So I could do this by hand by plugging in a 1, plugging in a 2, a 3, a 4, a 5, and a 6. Add all those 6 answers together, and this would also give me a sum of 126. So that can be done without the calculator stuff as well. So that's always an option. And that's what I did right here. You can also use the formula. If you are finding the sum of terms 1 through 6, that means you have 6 terms. I plugged in the first term right here, the common ratio right here, and that can all be done with the formula. To identify some of that information, though, you're going to need to sub in some numbers. I had to plug in a 1 for k in order to get the first term of the sequence, which is this part of the formula. I then plugged in a 2 for k, so 2 to the 2nd power, to get the second term, because I needed to do the second term divided by the first term in order to get my common ratio. That way I could use the formula. So that's another option. You always have options on these. So I'm going to show you all those options, and you can kind of go with whatever you feel is the best method for you.